Welcome, and now we have my promised workshop from tomorrow, and it is oriented to and for ancient element, and we prepared with Dario and with colleagues from here chemistry part for you 13 experiments oriented to 4 ancient elements, and you can see. And I prepared for you English instruction for each experiment, but sometimes it is not experiment in whole, but sometimes it's only one operation and so on. And maybe I would like to introduce something what we work with these experiments, and next you can find in couples or individually one experiment, and I will give you 10 minutes and you will try to make this experiment and to prepare a presentation for all of us. And next we will go one to one experiment presented by you, and so on, so on. And in the last part you can try what you like. And also you can make the photo if it's interesting for you, you can make for your using. Eventually you can write me to my email. I have also German version, but I don't have Lithuanian version. I have Czech version, German version and English version. But as I promised, it is about ancient element, and you know what means ancient Mediterranean Greek and so on, but it is not important now. And you know the Greek philosophers was the something elite of the Greek society, and they worked many on theory. They work on the first theory for some experiential approaches in nature and the science. And also, yesterday I spoke about monists, Thales from Miletus, all was from the water, Anaximander, all was from the apeiron, what means some mystery substances, Anaximen, air, Pythagorean number, as I said yesterday, Heraclitus fire, and so on. And Empedocles combine 4 elements: fire, water, earth, and air. And next, Aristotle made a bit more sophisticated theory, as I presented yesterday, was 4 principles, like properties, and 4 elements. And also parallel, we are scientists. We are working in science education. We have to pay attention also on the parallel theory. It was discontinuous particle, atomos, not to splitting. And it was one Anaxagoras, maybe you know Democritus and Leucippus, somewhere 500 or 400 before Christ. And interesting is that this theory was really phantasmagoric. It was really nothing what I can see, what I can to use, what kind of, and 2000, as I yesterday said, 2000 years was hidden. This theory was hidden and was renovated, you know, in 17th, 18th, 19th century. And now for the experiments, and here is Aristotle, as I presented yesterday, and with my colleagues from Germany, we worked in these experiments oriented to 4 ancient elements, and this is oriented mainly for primary education. Something you can use also in pre-primary, but not so much. These examples are for higher education. But why the Nessie? You know Loch Ness from the Scotland. Loch Ness. Yeah, okay. is from German, but the daughter of my colleague from German prepared this acronym. This acronym means Nürnberg, Erlanger, Schülerinnen Lab. But it is together Nessie, and they have Nessie Lab. And we are working with water, with fire, with earth and air. And also we have a little bit more sophisticated project in Prague with these 4 ancient elements. Maybe it will be for you more motivated. And we use the storytelling, and we use more mystery for it. But for example, fire is connected with God, ether, eternal flame, and we are modified it in warming magnesium plus water. You know, magnesium powder and 1 drops of water, and we have the big fire. And Hephaestus, magical vision of the funnels. It can be oriented, maybe it's also from experiment. Oxidation means plus glycerol, and we can make the flame. But it is not for primary, it is a little bit more. Earth, Gaia, it's God, goodness of the earth, chemist garden. Maybe you know chemist garden and different ions in silica gel, and we can grow something like flora in the chemistry. And Prometheus, you also know Prometheus, detachment from the rock, and could be destroying of limestone through the acid, chloric acid. And it's only 2, but we have also next one. We have water, oceanos, origin of the seas, hydrogen, working with hydrogen, dangerous. Pontus and Thalassa, and a lot of small seas, colored warm and cold water. We have here this experiment. This is also possible to use on the primary. And last but not least is air, Uranus, full of sky and clouds, working with nothing. Maybe you know, we are working with nothing, with carbon dioxide, but we can distort the flames and so on. And also Earth's boiling for some cases, dioxide and air vapors and working with those. And also we have now, it's very popular in our department, maybe you know what means University of Third Age. It is university for seniors in our university, it's very popular. And also we prepared this concept of 4 ancient elements for seniors at our department. We are working with these 4 elements, and also we add something more, ancient element plus art, ancient elements plus music, water in something, and also elements in education. It is about concept. Now it is maybe some question? No, all is clear. All is clear. Okay, so now we can start. You can elect, each of you, couples, pairs, or individual, please elect 1 experiment. And in this case, we can work these 2 together. This is really only 1 operation, and these 2 experiments you can integrate in 1. And I will give you 10 minutes. You can try it, prepare, and next we will go from 1 to 2nd experiment, and you will, maybe, Vincentas, maybe you can speak in Lithuania. If you will work with this experiment, maybe it will be for me also interesting to listen it in your language. And I will be with you. I can advise you, but only first advice is for these 2 experiments. We are using oil, kitchen oil. We are using kitchen oil, and will be nice to use kitchen oil colored by paprika. Colored by something, but yesterday we bought with Vincentas paprika. You can use the paprika, and it is 1. And I think all next is it's okay. You can try. So now selection next 10 minutes, and next presentation of your. You need an hour later.
Nenoriu visai suvaidinti. Čia tikriausiai duota aliejus, jo, bet čia galima tiesiog aliejų pilti, bet sakė aliejų nusidažyti, gal dėl to yra duota. Sakė, kad galima.
O su paprika nedažnėt nepaprika?
Taip, bet jeigu jūs užpilsit, tai jau tada nesusimaišys, tai pirmiau reikia padažyti.
So next 4 are here also. Next 4 are here. You can have it from here.
Fill up a small bottle for with herbs.
Jo, bet sakė, kad jums reikia aliejų nežėti. Tai va, kaip čia šitą.
No.
You have some idea how to make it? Hold it up, hold it up.
Išpilti čia. Išpilti. Kelis dešimtmečius
And be careful, but just is stream. Okay, it's enough. It's enough. And please little bit shake, and you have extinction. Shake, and fire is extinguished. Growing up. The first finished, second finished. And carbon dioxide is growing in the brain. Now we are waiting for this liquid. We need a big amount of carbon dioxide. In this form, I was under carbon dioxide. He's too big. The baker.
The previous group was successful in the previous group.
Now it's battling. Now it's battling. Now it's battling. Now we have somewhere here.
Small muscles started to come even when I didn't put
Yeah,
this.
it is very sensitive for saponate. It must be totally without saponate at the start.
Yeah,
We can make it once again. We can make it once again.
Please louder, louder.
And please
to speak louder.
Please take the water here.
Yeah.
Take the water.
Martin, good experimentator, right?
Yeah.
So skilled, so skilled.
We are chemists.
Yes, yes, right. With high competence level. And now you are mixing mixture.
Now I am coloring oil. I am
Coloring oil.
Only coloring.
Yeah,
oil.
with paprika. I want to remind with paprika.
It must be something what is soluble in oil.
In oil, right.
Not the Easter colors. They are for the water. They are not for oil. Okay. And now we take this one.
And now what we are doing?
Now we are filling the small bottle.
Yeah, small bottle. Very small, very little bottle.
Till the okay.
Full, right?
Full. Totally full.
Totally full.
And now I will put it in water. Oh, maybe I need something. I have somewhere.
Galima palenkti rindėlį. Mes stebėtojos iš apačios.
Yeah, because you have to do it slowly, and I just dropped
It
it.
will be better.
I just dropped
Yeah,
it.
with some
And
instruments.
your drop.
Yeah, I just
okay.
dropped it like this much.
Yes, slowly. With special device.
See?
Yes, and now. Yeah. And now his Jenny is going up, but we have little bit saponate somewhere, but originally the Jenny it's in small bottle. It's not going up. The water need decrease a little bit surface, but also was not okay. but maybe was the sea. And if we put a little bit more saponate, maybe we have.
Okay. It's better.
It's better.
I think.
Yeah, but it is very, very sensitive for saponate. It must be totally, the glasses must be without saponate. And 1 drop of saponate is open door for the oil.
Yeah. But I understood the principle of
Yes,
everything.
principle.
So.
Well done, well done.
Oh.
Yeah.
Vandens antideminacija.
And for the next one, use the dry one. Dry it once again. And if you have the wet inside, it is working just. But it's better to use the dry one. Super. You can try it once again.
Yeah, please try once again because we want to record your work in order to give a final mark afterwards.
Maybe tablets are a little bit old.
It works.
It works, but not so.
Aš nežinau, kur man rankos. Vandens nedaug čia, gal užteks.
And just close.
Svarbu laiku pasilenkti ir kada kiek žinai. Aha.
It's better like before, better like.
Spalvom, tai šalta spalva neišeina, o šiltas vanduo greičiau skleidžia šilumą ir atsiranda spalva. O kur su ledu darytas eksperimentas, iš vis spalva neišsiskiria į vandenį, va čia galima matyti.
Ir kokia išvada?
Kokia išvada, kad šaltas vanduo, šaltame vandenyje molekulės gal lėčiau arba iš vis lėčiau sklinda. Gal tokia?
Abejonė visada lieka, na bet priimkim atsakymą.
Na, priimkim.
We poured vinegar, then put it.
I explained it to you. Uždegėm žvakes ir tiesiog šitą tada įstatėm čia į indą, degė žvakės viduj, tada įdėjom sodos tabletytę sumetėm ir tada pradėjo gesti visą žvakę.
It's here somebody to write chemical reaction, soda plus acid, vinegar acid. What are the products? What are the products? Soda is react with acid, and product is CO2, carbon dioxide, and water also, and some salt. you know, some salt from the acid, from the, it is vinegar. What is English name for vinegar acid? Acetate. Yeah. Sodium acetate. It's final product of this reaction. CO2, sodium acetate, natrium acetate, and plus water. So, and reverse experiment could be that after your experiment, we have here CO2. We have here somewhere we have niveau, somewhere we have niveau of CO2, and we can try it. I will make once again burning of the burning of the candles. It's biggest, smaller, smallest. Okay, and now the children can try where is the surface of the CO2. Not yet.
Slowly.
Not yet. Slowly, very slowly. And the smallest one. It's probably is out, but we have to produce new one. Yeah, it's producing, and our hypothesis is the smallest one first will be out. Yeah, and production is coming, is going, and now you can see that here is bubbling. Lost. First one lost, and next the second one will lost. Yeah, we need more and more CO2. It is a general product, but you can use different kinds of eating soda or soda. Now it's bubbling. The white one is bubbling now. Now, yes. No, not yet. No. So okay, and could be some competition between high of the. Thank you very much. And we can try to put the paper inside of the liquid, but it's better to work this way. We need the gap inside here.
So we need the knot. It is a little bit different, like in my lecture yesterday. Yes, this is knot, yeah. Okay, and now I am recommending brown marker and black one. It is for children. It is big surprise what is inside of black one. And we can use also, for example, green one and some red. You can try what will happen. And now it's better to put it not inside of the water. And now through this knot, its water is going up and approaching to color. I remember my yesterday, I made the knot in this way. Maybe this is faster. This is faster. Yeah, this is faster. And we can use also this one. We can borrow here. Now it's approaching to
approaching to
one. And do you know somebody now story about this method, about this chromatography? Who was the founder of chromatography? Founder of chromatography was a Russian chemist. And it is not a joke, it is reality. The name of this Russian chemist was Tsvet. And you know that Tsvet is color. But chromatography is methods about colors. But founder has named color, Tsvet. Yeah. So, okay, it can work here.
Of this bigger jar with water, a little bit more than a half. Then I had a small brown bottle and I had to put it oil, but colored one. So with paprika, we colored oil and put it in the small jar. Then we had to slowly put the bottle. You cannot drop it, you have to put it. So this jar is a little bit too narrow to do it. So we used scissors and we put it, and the oil started to go up like a genie, and it had a beautiful color. And then we put washing detergent, 4 drops. Oh.
It's okay.
And,
now it's no problem.
Yeah, and it stopped.
And what is reason that in first step the oil is inside of the small bottle? Why is not just if we put the bottle in water, bottle is oil in the water, why the oil is inside and not going up? Why? What is the phenomena?
The mixing, you mean?
You know, Dario now. Dario must be quiet. Somebody knows what is the phenomena on the water that the colored oil stayed in the small bottle. It is surface tension of water. Water has big surface tension and pressed on the top on the small bottle. And if colleague use the saponate is reason for decreasing of surface tension of the water, and in this time oil can be go up. Okay? So thank you.
Paprastai įpylėm vandens, atskirai nudažėme aliejų su paprika ir kai mes pilame,
Now could be the first effect. You can see. First effect is something like lava. You can took more. You can take more. Yeah. This first
First step of lava. And second step of lava.
I need to put salt.
Now we will put on the salt, and we can observe. Maybe you can make it here. You can use this. Yeah. I saw some Russian paint. Put salt. Not so much, a little bit more. Less. Yes, this is good enough. This is good enough. And you can see the effect. And what is the effect? It is about three kinds of densities. One density is water density. Second density is oil density. And third density is solid, is the salt density. Which one density is highest? We have three substances: water, oil, and kitchen salt. Which of these three substances has highest density? Oil, water, or salt? Salt, yeah, geologist. Salt has highest density. Second in the order, oil or water? Second highest density. Highest density is salt, second oil or water? Paprika is not important for this. Water, okay. It means that water is down and oil is up. It is very important for primary education to distinguish between density and viscosity. You know what means viscosity. Viscosity, for example, honey. Honey has big viscosity, or oil has big viscosity, but not big density. But many children don't distinguish between density and viscosity. Honey and oil has bigger density like water. But here is the example not. Oil is floating, it must be less on the density. Yeah? Okay, this is first one. And second one is our effect. Salt, your salt, is falling through the oil down, and reason for this is density. Highest density in comparison with oil and water is that salt has highest density, and falls down. And together with this falling, catch little bit oil with the salt to down. And if oil is down, density is less like water, oil go up. And please, once again, and be prepared. You can read on the tube, and also carbonate. And now I will put. What happens if I put table to oil? What happens? Hypothesis. We need a hypothesis, inquiry-based science education.
Based on evidences.
Based on a hypothesis, reaction, tablets with oil.
Empirical
Reaction.
testing.
Hypothesis and reaction with water. Yes, but it is that answer. It is not reaction. Water is also solution. So the two substances, acid and carbonate, and reaction will come. React carbonate. Now we can try. So a little bit oil, like in the and now it's slowly starting reaction between acid in the tablet with carbonate, and we are producing CO2, and you can look on this layer of oil, and this is just opposite. Salt falls down, but gas is growing up, and if gas is growing up, take
with him, with it, up a little bit water. And water has bigger density like oil and force. But it is nice that the first experiment is from, like Andres brought.
Yes.
From up to down, and next experiment from down to up. Yeah. So, and now it's, I think it's an effect. Not effective, but effect. Effect. Okay. Thank you very much. Thank you. And yeah.
Mes atlikom eksperimentą, tai pačią savo užsivertėm, kad gesintuvo efektas. Tai įpylėm 3 cm vandens, tada įpylėm 4 šaukštelius indų ploviklio ir tada 4 šaukštelius acto. Tada viską suplakėm ir uždegėm popierių. Uždegėm popierių, tada į šitą indelį įpylėm truputį kepimo miltelių. Ir tada suplakėm, pradėjo pūsti ir greitai užgesino ugnį.
Yeah. But they have to be careful, but just after small shake, we are received the foam. We are, in my language, piena, in your language, foam.
Putos.
Putos. Okay. So, thank you very much. And
Čia mes aprašėme nebuvo jos. Tai va, o paskui čia viskas paaiškėjo, yra monetos tokios sunkios, jas reikia nuskandinti vandenyje. Čia guminukai buvo, čia mūsų laivelis su plaukikais.
yes, like cement.
Ir čia yra magnetas. Ir kai ant stiklinaitės tą padėjo ir apliejo vašku magnetą, tada, žinot, viskas buvo gerai, laivelis plaukė ir ištraukė ir prisikabino tą pinigėlį. Nes kitaip, suprantat, jisai pats skęsta. O kai apliejom, jis nebeskendo. Ir tada tas privyko prie galo. Tai va, toksai buvo mūsų eksperimentas. Bet esmė tai žvakė. Sakau, nebuvo prašyta, kad tai reikalinga, o pasirodo reikalinga. Skaitom, čia yra žvakė.
No, thank you, and show us this. How you made it? Please show it once again. Yeah. Now it's floating. Yeah.
Va, matot, skęsta. Jisai visas skęsta.
We have to make must float. Only one seaman. It is too heavy. 3 are too heavy. And now it's floating. And we need to catch the coin from down to up. But the seaman must be dry. Please.
Kur man, Evgenija, tikit, ką jūs ten darėm?
Aš užlydžiau šitą.
No. We don't need. We have magnet here. And it is more simple. Now it's floating. The seaman is floating on the boat, and treasure is at the down.
Yeah.
And seamen need to catch the treasure up. And how to make it? This way. Now magnet is in function, and now we go up.
Gerai.
And now the seamen catch the treasure at the down. Yeah?
Why do we need candle?
Candle we don't need.
Don't need.
We need candle only if magnet put out.
Yeah,
we have to glue.
magnet.
We have to glue the magnet to the boat. But it's nice in the same approach to start. And magnet will be out. And children, please think about how to make it. And children must think. Okay, we have to glue the magnet on the boat. And we can make this one. Okay? This is principle. So, thank you. Cold water, and now the hot water. It is not usually to have hot water in love. And here is a rich country. Lithuania is a rich country.
Yes, you are right. Absolutely right.
So, and
Because it's center of Europe.
yeah. And so we have the air inside in the lab temperature, and now we can start, for example, with hot water. You can observe the balloon. Go. Yeah, it's a little bit counterproductive that glass is isolant. We have to fight for it. Eventually to have higher temperature from the heater. It's a little bit more, but now I can put it in the cold water, and you can see that we will go down. So, and maybe it will be nice STEM approach to start in this way, to prepare cold air, Okay, and now make snow. Yeah. It's growing. Not so much, but yeah. Better is high temperature. Or at the start being more cold. Okay, we can put it here and we can wipe.
Ir pučiamas oras. Kai mes pučiam, susidaro kamštis, uždaro kolbą ir viskas, ir mes nebegalim daugiau pripūsti. Nes koks yra tūris kolboj, toks ir yra, ir jo nei daugėja, nei mažėja. Tuo tarpu, kai mes įdedam šiaudelį ir pučiam orą į balioną, mes galim balioną pripūsti. Kodėl? Todėl, kad yra tam tikras tūris kolboj, bet įėjęs oras išstumia lygiai tokį pat kiekį oro laukan per šiaudelį. Fizika.
It is next confirmation that air is something. Air is not nothing, air is something. And next one. It is also about surface tension.
Taip, turim vandens. Į vandenį beriam kūdikių pudros.
You can use also pepper or something small, some small pieces.
Ką matom? Matom, kad pudra stovi ant vandens paviršiaus. Žinom, kad vandens yra toks dalykas kaip vandens paviršiaus įtempimas, kuris neleidžia pudrai nusėsti žemyn. Tuo tarpu, lašindami muilą arba skystį. Parašyta, kad reikia 4 lašų. Po pirmo lašo, ką mes matom, kad pratrūksta ta plėvelė arba vandens įtempimo paviršius ir kas darosi? Pradeda pudra leistis žemyn. Tai reiškia, kad mes pralaužiam gardelę ir vyksta kas?
So, and we see that powder is falling down, the surface was destroyed. Not totally, but what decreasing. And some of my students make different experiments, for example, to use the surface tension also for what means this svorka. And if you have many paper and you make together.
Drakoniukas.
Yeah, and also it can float on the surface tension. But it must be very pretty to make this experiment. But powder it's okay, it's floating and you can use the powder. Okay, so next we can go here.
Tai turėjome 2 tuščius buteliukus. Į vieną buteliuką įpylėme karšto vandens ir raudonos spalvos dažų, o į kitą priskaldėme ledo šalto ir įdėjome mėlynos spalvos dažų. Tuomet į vandenį panardinome abu buteliukus, apvertėm Ir raudona spalva iškilo į viršų, o šalta spalva apačioje liko. Tai reiškia, kad
Šaltas is cold, yeah.
Šaltas spalva, yes. Ir tiesiog po to galima buvo įdėti ranką ir matėsi, kad viršuje šiltas vanduo, apačioje šaltas vanduo. Tai tiesiog šiltas vanduo ežeruose, galima paaiškinti vaikams jūrose, laikosi aukštai, jisai kaip ten yra lengvesnis. Ar kaip? You will explain why it is so that warm water is up and cold water is down.
It is also about the density. Hot water has less density like cold water. And we can see it in the bassins, in the swimming pools. But be careful about winter. And in which temperature has water biggest density? In which temperature has water biggest temperature?
From -4 to +4.
+4. But it is very complicated how to explain differences between solid, liquid and gas. Theory. What seems in theory? Theory seems solid from the same substance has biggest density. Liquid little bit less and gas smallest. But now water. First example, simple liquid is water. And what about ice? Ice is solid, must be higher density like liquid. But it is not right. You can try it. Box of the ice on the liquid, on the water, and was not falling down, but it is floating. Yeah, but it is exception. It is exception for the water. But water is not simple. But many times we are writing in textbooks. We have to start in science education with water. Water is most simple liquid. It is not simple. It is very complicated. Water is very complicated, and it is exception in this. Right. Okay. Thank you very much. Thank you very much. And now use the same. And now we can try. First. Second. It is Czech coins. Maybe five, maybe five, yeah. And this is something like blue. And what is name for this phenomenon in physics or in chemistry? What is this phenomenon? Name, professional name for it? Adsorption. Adsorption. The paper absorbs the water, and this is like. Okay. Nile. We can start. Please start with Nile. Start with Nile.
Oh, yes, I know. I just.
Okay, you are prepared. Okay.
Taip, tai pirmiausia, vieni deginam, tik tai kaitinam. Ir čia eksperimento esmė, kad reikia stebėti, kas vyksta su medžiaga. Tai realiai vinis įkaista, bet, jisai neužsidega, jis pakeičia spalvą, trūksta, bet šiaip neužsidega. O dabar paimsime tos pačios geležies plaušas, ar kaip jis čia vadinasi. Ir jo degis. Tai gali ir žiežirbų būti.
So it's good to ask the children. Does iron burn? Does iron burn? No. But we can see that if surface is bigger, iron can burn. Yeah. Okay. Not so much, but fine.
Jo, bet pamatot, kibirkščiuoja. Čia gal reikėjo labiau papūsti ją tokią.
Yeah, it's okay. It's okay.
So our board, thank you very much.
Thank you very much, Martin. It's well done as usual. Well done as usual.
I cheat.